Hello everyone. In the last class I have explained the problems on non-homogeneous differential equation with type 1, type 2 and type 3 phi of x functions, that is an exponential function, a trigonometric function, or phi of x is a polynomial. In today's class I am going to solve the problems on non-homogeneous differential equation with all the three types of function, which is a combination of the previous three types of function, that is an exponential or a trigonometric or a polynomial. So let us take the first problem, that is solve d square y by dx square minus 4 dy by dx plus 4y is equal to e power of 2x plus cos 2x plus 4. Here e power of 2x is an exponential function, that is type 1 function. Cos 2x is a trigonometric function, type 2 function, and in the last term we have a constant element. For this constant element, either we can write this one in type 1 form, that is in exponential form as e to the power of 0x, or in trigonometric function form or as cos 0x. We can write this as 4 into e power of 0x, that is in type 1 form, or cos 0x in type 2 form. We can apply either of the form to solve this differential equation. So for that, first let us find a complementary solution, that is the solution of the LHS part of the equation. So given equation can be written in differential operator form as d squared minus 4d plus 4 of y equal to e power of 2x plus cos 2x plus 4. So this is the given equation. To find the complementary function, we have to consider the LHS part of the equation, and this is phi of x. This can be written as f of d of y is equal to phi of x. F of d is the differential operator function. Phi of x is the given function in terms of independent variable. To find the complementary solution, let us write the auxiliary equation from the LHS part of the equation, that is by replacing d by m square minus 4m plus 4 equal to 0. So this equation can be written as, we can easily factorize this, m square minus 4 can be written as 2 into m plus 2 square equal to 0. This is in the form of a square minus 2ab plus b square, where a is equal to m and b is equal to 2, that is m plus 2 whole square. Hence the two factors are m plus 2 equal to 0, m plus 2 equal to 0. Then we get m is equal to minus 2 comma minus 2. So we get a real and coincident root. Coincident means equal roots. The roots are real and coincident here. Therefore for the obtained root yc, that is complementary solution, is equal to, for the coincident root, c1 plus c2x into e to the power of the obtained root, that is minus 2x. That is the solution of the complementary solution of the given differential equation. Next, to find particular integral, that is to find yp value. To find particular integral yp, formula is yp is equal to phi of x divided by f of d. Phi of x divided by f of d. So substituting phi of x and f of d, phi of x is e to the power of 2x plus cos 2x plus 4. As I already told, we can write this 4 in terms of an exponential term or in terms of trigonometric function. Choose the simplest one. I will take e to the power of 0x and denominator value f of d, that is d square minus 4d plus 4. So then solving this by applying suitable procedure, for e power of 2x, that is in type 1, we have to replace the denominator d value by 2. For a trigonometric function, we have to replace d square by minus 2 square, and we have to solve this till we get a non-zero denominator. So let us solve this. Then yp is equal to e power of 2x divided by, split the elements, first element by the denominator, d square minus 4d plus 4 plus the second element cos 2x divided by d square minus 4d plus 4, and the last element 4 into e power of 0x divided by d square minus 4d plus 4. First I will take exponential function. Here we have to replace d by 2. In the last term, it is also an exponential term. We have to replace d by 0. But in trigonometric function, we have to replace d square by the constant element, that is minus 2 square. The constant element is minus 2 square. So replacing that, yp is equal to, we have e to the power of 2x. Substituting value, 2 square is 4 minus 4 into 2. D value minus 4 into 2 plus 4. In the second term, cos 2x divided by, on replacing d square by minus 2 square, that is minus 4 minus 4d plus 4. Last term, 4 into e power of 0x. In the next step, we can write that e power of 0x as 1. Denominator value 0 minus 0 plus 4. Here in the second step, the value of plus 4 minus 4 get cancelled. We left with minus 4 into d. Here d term exists here. If d term exists in a trigonometric function, we have the following two steps. Either we can multiply by its conjugate, that is minus 4d is there, the conjugate is plus 4d, multiply by 4d or multiply by 4d and divide by 4d. Or the value of 1 by d, the value of 1 over d is nothing but integral of the function, that is minus 4 integration of cos 2x. 1 over d is there, so integration of cos 2x. And in the first term, we have 4 plus 4, 8 minus 8. The value of the denominator term is equal to 0. If the denominator term equal to 0, then in the next step, while writing particular integral, we have to multiply the independent variable, that is x here, x into e power of 2x, and we have to divide the denominator term. We have to differentiate the denominator term. Differentiation of d square is 2d minus differentiation of 4d is minus 4 plus differentiation of constant term is 0. In the second term, we have minus here, minus 1 divided by 4 is the constant term, remaining 1 over d of cos 2x, and integration of cos 2x is sin 2x divided by 2 plus 4, e power of 0x is 1 divided by 4, and the value of 4 get cancelled, remaining term is 1. So now the solution of the last two parts are completed. The solution of the second term and third term. Here d term eliminated and we get a non-zero denominator here. So then the solution of the last two term completed. We need to simplify the first term only. Here we have 2d minus 4. Again d term exists. We have to replace d by this constant term 2. Then yp is equal to x into e power of 2x divided by 2 into 2, 2. That is 4 minus 4. Second term is minus 2 sin 2x by 8, and the last term is 1 by 4. Again we have 0 denominator in the first element. Since we have 0 denominator, then yp is equal to, again multiply x to the numerator, x square e power of 2x, and differentiating the denominator, differentiation of 2d is 2, differentiation of minus 4 is 0. And the solution of last two terms completed, that is minus sin 2x divided by 8 plus 1 over 4 is the solution of, that is particular integral of the given phi of x, which is a combination of an exponential term and a trigonometric function. So x square e power of 2x by 2 minus sin 2x by 8 plus 1 over 4. Therefore, complete solution is y is equal to yc plus yp, that is y is equal to yc value is, here we have the value of yc is c1 plus c2x into e to the power of minus 2x is the value of yc, and yp is x square into e power of 2x by 2 minus sin 2x divided by 8 plus 1 divided by 4. So this is the solution of the given differential equation. Next problem on combination of type 1, type 2, type 3 function is d square y by dx square minus 6 into dy by dx plus 25y is equal to e power of 2x plus sin x plus x. In this problem, the given phi of x is a combination of all the three types. E power of 2x, that is type 1, an exponential function. Sin x, it is a trigonometric function, that is type 2, and x is there, it is a polynomial, that is in type 3. For that, to find the solution of the given equation, let us find the complementary solution. So the given equation can be written in the form of differential operator equation, that is d square minus 6d plus 25 of y equal to e power of 2x plus sin x plus x. Now phi of x function is e power of 2x plus sin x plus x. So this equation can be written as f of d of y is equal to phi of x, and the auxiliary equation is m square minus 6m plus 25 is equal to 0. For this root, since it is of degree 2, we get two roots here. To find the two roots, first let us check if it is possible to factorize this. Observing this value, we have minus 6 and 25. So we can't choose two numbers which satisfying these values, that is minus 6 and 25. So factorization is not possible. I am applying the formula here. A is equal to 1, B is minus 6, C is equal to 25. Hence the formula is minus B plus or minus B square minus 4AC divided by 2 times of A. Substituting the values, B value is minus 6, minus of minus 6 is plus 6, plus or minus 6 square, that is 36, minus 4 into 1 into 25 divided by 2 times of A is equal to 1, that is 2. 6 plus or minus square root of, simplifying the square root element, 4 into 25 which is equal to 100. 36 minus 100 is equal to minus 64 divided by 2. Simplifying again, m is equal to 6 plus or minus square root of minus 64 is 8i. Root of 64 is 8, root of minus is I, that is an imaginary term, divided by 2. On simplifying again, 6 by 2 equal to 3 plus or minus 8 by 2 equal to 4i. So this is the obtained root, which is a complex root, 3 plus or minus 4i. Therefore, complementary solution yc is equal to e to the power of real element is 3, e to the power of 3x into imaginary value is 4, c1 cos 4x plus c2 sin 4x. So this is the first part of the solution of the given equation, that is complementary function. Next, to find particular integral, to find yp, we have yp is equal to phi of x divided by f of d. Phi of x divided by f of d, and we have all the three combination, that is type 1, type 2, type 3. We have to apply the procedure of all the type. First one, we have e power of 2x. The value of f of d is, here we have d square minus 6d plus 25. In the second term, we have sin x divided by d square minus 6d plus 25. In type 1 and type 2, while writing the value of f of d, we write as it is. But in type 3, if phi of x is a polynomial, while writing phi of x and f of d, we have to write phi of x in descending powers of x and f of d in ascending powers of d. Since for phi of x we have only one element, that is x, I write as it is, and writing the value of f of d in ascending powers of d, we have d square minus 6d plus 25, writing in ascending powers 25 minus 6d plus d square, and we have to divide these two equations till we get a zero remainder. Then the resultant quotient will be the particular integral for this term. We have to find particular integral separately for all the three terms using three different methods. In exponential term, we have to replace d by the constant. Here we have 2. we have to replace d by 2 till we get a non-zero denominator. In the second term, we have trigonometric element. For trigonometric element, we have to replace d square by minus a square. In this term, a value is 1. We have to replace d square by minus 1 square. So let us substitute. So in the first term, that is in exponential term, we have to replace d by 2. In exponential term, we have to replace d by 2 since d2 is the constant element here. In trigonometric function, we have to replace d square by minus 1 square. And in the last term, we have to separately divide these two. Now yp is equal to e power of 2x, denominator value on replacing d by 2, 2 square is 4, minus 6 into 2 plus 25. 4 minus 12 plus 25. In the second term, sin x divided by d square is replaced by minus 1 square. So we get minus 1 minus 6d plus 25. So we have to divide this. Later I'll divide separately that one. First I'll simplify the first two. Next yp is equal to, in the first term we get e power of 2x divided by 25 plus 4 29 minus 12. 29 minus 12 is 17. The value of the first term is e power of 2x divided by 17 plus sin x divided by minus 1 plus 25 is plus 24 minus 60. Here d term exists. Since d element exists, we have to multiply by 24 plus 60. That is conjugate of the denominator. 24 plus 60, 24 plus 60. We have to write one more term here, that is by dividing the last term. And here the solution of the first term completed. We need to simplify this. Yp is equal to e power of 2x divided by 17. On multiplying its conjugate, simplifying that, we get 24 into sin x plus 6 into d of sin x. The value of d of sin x is cos x divided by 24 minus 6d into 24 plus 60, that is in the form of a minus b into a plus b. The value of a minus b into a plus b is a square minus b square, where with the value of a is 24, the value of 24 whole square is 576. 24 whole square is 576 minus a minus b into a plus b is a square minus b square. B value is 60, 6 square is 36 into d square. So we need to write the solution of the last term. Yp is equal to e power of 2x by 17 plus, on taking 6 as common term in the numerator, the remaining element is sin x plus 4 sin x plus, we have 24 here, on taking 6 as common term, 4 sin x plus cos x divided by, since we have d square element here, we need to get a non-zero denominator without d or d square element. Since we have d square, here we have to replace d square by the coefficient of trigonometric element is 1. We have to replace d square by minus 1 square. Substituting that, 576 minus 36 into minus 1 square, that is minus 1, plus again last term. Simplifying again, yp is equal to e power of 2x by 17 plus 6 into 4 sin x plus cos x divided by 576 minus of minus plus 36, and the value is 612. So we can simplify this. 6 ones are 6 1. So the remaining 0 2. 102 plus again the last term. So now we need to find the yp part of yp value of the last term, that is a polynomial. Up to here the solution of an exponential term, the solution of first phi of x function and the second phi of x function completed. The remaining part we have to find the yp of the last term, that is x by 25 minus 60 plus d square, by dividing that to equation. Here I am dividing that. We have to divide x by What is the value? 25 minus 6d plus d square. We have to divide by this term, 25 minus 6d plus d square. To divide this, we have only x element here. We have to divide this till we get a 0 remainder. Then the resultant quotient will be the yp of the last term. To divide this, what is the value of the first quotient? For that, divide the first term, that is we have the only element, by the first divider, that is 35. So the first element is x divided by 25. So simplify that, 25 into x by 25, 25 get cancelled, remaining element is x. Next, the second term, we have here minus 6d of x by 25. Minus 60 x by 25 minus 6 by 25, writing as it is, minus 6 by 25, differentiation of x is 1. So the remaining element is minus 6 by 25. On differentiating once, we get a constant term here. That means here in the next step we have d square, and differentiating one more time, differentiation of a constant term is 0. The next term is 0. Continuing the division, simplifying this, minus x plus x get cancelled, and here we have positive sign, we get 6 by 25. Next, to find the next quotient element, divide the obtained element from the divider, that is 6 by 25 divided by 25. 6 by 25 divided by 25, which is equal to 6 by 25 into 25. Which is equal to 6 by 25 into 25, that is plus 6 divided by 625. 6 divided by 625. So now multiplying that, 25 into 6 divided by 625. Simplifying this, 25 ones are 25 twos are, sorry 25s are, the resultant term is 6 by 25. Next element, minus 6d into 6 by 25. Since 6 by 625 is the constant term, differentiating that we get 0. So the remaining term is 0. Simplifying this, we get minus, plus and minus term get cancelled. We get a 0 remainder. We have to continue the division till we get a 0 remainder. We have 0 remainder here. Hence the resultant quotient will be the yp of the last term. What is the obtained quotient element here? X divided by 25 plus 6 divided by 625. X divided by 25, 6 by 625. So here for the last term I am writing the solution. X divided by 25, 6 by 625. So similarly the next two, 6 by 625, x by 25 plus 6 by 625 is the complete solution of yp for all the three types of phi of x. That is for an exponential term, a trigonometric term and a polynomial equation. Therefore final solution is y is equal to yc plus yp, where yc value is, here we have e power of 3x into c1 cos x, e power of 3x into c1 cos 4x, we have c1 cos 4x, c2 sin 4x, that is the complementary function. Particular integral value, we have three different elements. For exponential term, e power of 2x divided by 17 plus the next term 4 sin x plus cos x divided by 102, and for the last term x by 25 plus 6 by 625. So this is the solution of a non-homogeneous differential equation with a combination of all the three different types of function, that is an exponential and a trigonometric and a polynomial.